We're still going to do some more proving the identity. Again, this chapter is all about proving the identity. Um, these ones are just a little bit more complex from the previous video, but it's the same tactic. Yeah. So for example, the first example, tangent of y plus cotangent of y over cosecant of y equals secant of y. Again, I told my students the variable doesn't matter. Okay. You can use y, x, z, whichever you want, um, as long as you're, consistent with like everybody else. So you can change it to x if you want, theta if you want. I'll just keep it simple. I'll just leave it with y. Now remember the strategy. First, look at the two sides. Which one is hardest? Well, clearly the left side has more content than the right side. Therefore, I'm going to start with the left. And then, what was the second strategy? Well, personally, I like to work with sines and cosines. I don't like to work with tangents and cotangent. Again, that's not the easiest way. That's not the fastest way either. It's just the way I know how to solve the problem. So I'm going to start with tangent, cotangent, and cosecant and change it into sines and cosine. So sine of y over cosine of y plus cosine of y over sine of y over 1 over sine of y. Okay? Now, as always, when you have a fraction, common denominator, multiplying the left side by sine over sine, multiplying the right side by cosine over cosine. So sine of y over sine of y, sine of y over cosine of y, plus cosine of y over sine of y, cosine of y, cosine of y, over 1 over sine of y. Okay? Now, if we continue this way, sine times sine, right? Multiplying across is sine squared over sine cosine. Then cosine times cosine, again, is cosine squared over sine cosine over 1 over sine. Now, once you have a common denominator, you can put you can group them in the same denominator. So this is going to be sine squared y plus cosine squared y over sine y cosine y over 1 over cosine y. Oops, not cosine. Sine. Now notice that the technique is always to get a fraction over a fraction in order to multiply by the reciprocal. So now let's use one of the identities. What is sine squared y plus cosine squared y? Well, that's the Pythagorean identity, which is equal to 1. Okay, so this numerator, all of it, sine squared y plus cosine squared y is equal to 1. So I'm left with 1 over sine y cosine y over 1 over sine y. And again, flip the denominators. You have 1 over sine y cosine y times sine y over 1. Now again, we multiply across. So 1 times sine y is sine y cosine y. Sine y divided by sine y is 1. And this is a common mistake. I still haven't figured out why people make this mistake. But the cosine y is below the line. That means it's under the denominators. This is 1 over cosine y, which is equal to secant of y. Okay? And that will be your answer for that. Now for the next problem, let's choose a different color. Again, you have tangent, I'm going to start with the left side, changing it to sine over cosine. So sine x cosine x minus sine of x over 2 over 1 times sine x over cosine x. Now, sine x is over 1 as well, common denominator, so sine of x over cosine of x minus sine of x over 1 times cosine of x over cosine of x. In the bottom, you have 2 sine of x over cosine of x. Once you find a common denominator, you can group them together. So on the top, you're going to have sine of x minus sine of x cosine of x divided by cosine of x divided by 2 sine of x over cosine of x. Okay? Once you have this, you use the fact that fraction over a fraction, you multiply by the reciprocal. So I'm going to leave the numerator by itself, alone. Like I'm not going to do anything to it. And then on here, I'm going to multiply by the reciprocal, which is cosine of x over 2 sine of x. And by now you'll see I'm going to use the commutative property of multiplication. I'm going to flip these two guys. So on the left side, I'm going to have sine of x minus sine of x cosine of x over 2 sine of x. And on the right side, I'm going to have cosine of x over cosine of x. And the reason I do that, I swap these two, okay, is to get 1. So I'm left with the left side. So sine of x minus sine of x cosine of x over 2 sine of x. Okay. Now from here, I'm going to split the sign in both subtraction and addition. In the subtraction. So I'll have sine of x over 2 sine of x minus sine of x cosine of x over 2 sine of x. And the reason I do this is because notice that sine of x over sine of x is 1 over 2 minus sine of x is 1 cosine of x over 2. Now, if we factor the 1/2, you have 1 minus cosine of x. Now, this might seem like innocent here, right? What is 1/2 times 1 minus cosine of x? But if you remember from the half angle identities, this is the half angle identity for sine squared. So this is sine squared of x over 2. Okay? If you still need more confirmation on that, just look it up, half angle formula for sine. Okay, so that's what the answer is. Now the last one, notice that the left side has sum of angles and difference of angles, so I'm going to start with that. So I'm going to start with this guy. It's going to be sine of alpha cosine of beta plus sine of beta cosine of alpha. And then this guy over here becomes sine of alpha cosine of beta minus sine of alpha, not sine of alpha, sine of beta cosine of alpha. And notice you have addition and subtraction being multiplied, so we FOIL. So first, sine alpha times sine alpha is sine squared alpha. Cosine beta times cosine beta is cosine squared beta. Then outer sine alpha, sine beta, so this is a big term. It's sine alpha, sine beta, cosine beta, cosine alpha. And then the inner term is the same thing, but plus sine alpha, sine beta, cosine beta, cosine alpha. Then the last term is going to be minus, it's going to be sine squared beta cosine square alpha. Now notice that the middle terms is equal to 0. You're left with sine squared alpha cosine squared beta minus sine squared beta cosine squared alpha. Okay. Now from here we still have cosine squared beta, cosine squared alpha, and the answer is this without that. Let me see. I don't see anything wrong. Sine alpha, cosine beta, sine alpha, cosine beta, minus. I think I know. Okay. Let me see. Oh, okay. Let's change the cosine squareds. Okay. So I'm going to make this sine squared alpha as 1 minus sine squared beta. Okay. And then the same thing for cosine. 1 minus sine squared alpha. Okay, I distribute these two. So sine squared alpha times 1 is sine squared alpha minus sine squared alpha sine squared beta minus sine squared beta plus sine squared beta sine squared alpha. All right. And now notice that this term with this terms is equal to 0, and you're left with sine squared alpha minus sine squared beta, which is what we wanted. Perfect. So that's how you will solve that problem. If you have any questions, leave it in the comments below, or ask me in class. Thank you.